Welcome to a video on the intermediate value theorem. Let's recall what the theorem means. For a polynomial function, f of x, if f of a and f of b have opposite signs, then there is at least one real zero between the values a and b. So this is the short version of the IVT, which is also known as the intermediate value theorem. Consider going over example number 5. Determine whether the intermediate value theorem guarantees that the function f of x has a zero on the given interval. So on this given interval, we call this value a and this value here b. If we were to evaluate the function at -2 and at 0, and if they have opposite signs, then the theorem ensures that there is at least one real zero within that given interval. So that's what we're checking for. So let's start with evaluating f of a, which is f of -2. And f of -2 is basically substituting in a -2 for x here, and then performing the indicated operations. So power before multiplication. So this one gives us 2 times -8 plus 5 times the square of -2 is a +4. And now multiply. So this is -16 plus 20 and then -3. So f of -2 here is 1. And now we evaluate f of b, which is f of 0. And f of 0 here is basically the constant term there. Hence, this function value is -3, and the function value at -2 is a +1. So again, notice that these two outputs have opposite signs. And so if they have opposite signs, it's a polynomial function. It takes on basically all the numbers in between the interval -2 to 0. And if one of the output values is negative and the other is positive, the graph has to pass through the x-axis, which means that there is at least one real zero on that given interval. So the answer to this question is yes. And this work here justifies it.